Each of these problems in this lesson have a graphic organizer with them, and I'm trying to model how to solve linear combinations by defining the variables, setting up the equations, finding the solution, and make sure students are stating the units to the solution in their answer. When we go through and solve this, the first one, number 7, students struggle with the sentence, a shopper bought twice as many pints of strawberries as pints of blueberries. So I have to question them on how to set up the equation y equals 2x to get them through that productive struggle when some of the lower level students were stuck. And then we had the other one. Most of the time in most of the problems they were setting up, if you add the quantities together, x plus y, it would equal the total amount, but it confused students so they didn't actually give them the total amount instead of that statement. In number 8, the main thing they struggled with was not so much the elimination of the process of linear combinations, solving linear combinations using elimination. The most thing that they struggled with was defining what x and y represented. And I've talked about before, look at the question, what is the cost of one banana? So it's asking for the cost of one banana, so x could represent the cost of the banana, y could represent the cost of the apple, even though you're not eventually going to have to state the cost of the apple, you just need to find the value for x. And I talk about how to write the expressions based off of the words as you're reading. You can write the expressions above the words, and that helps some of my students that struggle with reading and interpreting word problems. If we go through and solve the first one, it has decimals in it. Sometimes I teach to eliminate the decimals by multiplying through by 100, but I also sometimes just model the decimals, and that's what I did in this case, just to show students not to be intimidated to solve the problem with decimals and fractions. So it's also a good example to be able to put y equals 2x from slope-intercept form into standard form, so students know that they have to put it in standard form before you can use linear combination to solve it, a system of equations, and that's going to be equal to 0. If I multiply through by negative 2.3, I'm going to get negative 4.6, not positive because a negative times a negative, 4.6, and then you're going to get negative 2.3, so that was with an x. Start this over, so it's 4.6x minus 2.3y equals 0, and when you bring down that top equation, that 1.6x plus 2.3y, most of the time when students get this far, they don't have as much problem solving it, equals 11, and remember you're just trying to find the sum of these two equations now. You end up with 6.2 equals x equals 11, and when you solve for that, x is going to equal approximately 1.77. Well, we have to talk about that these solutions are going to be approximate because pint shouldn't be part of a pint for strawberries and for blueberries. And so 1.77 is what you get for x, and when you plug back in for y, you actually get 3.54. So these are approximate solutions, and so really you would only be able to buy 1 pint of strawberries and 3 pints of blueberries. Now, if they said approximately, that it's almost 2 pints of strawberries and almost 4 pints of blueberries, but you can't buy part of a pint at the store. And so we talk about the restriction on that.